So the objective of this video is to be able to integrate powers of trig functions. So they'll come in this general form, which is the integral of sine to the m of x times cos to the power n of x, and depending on the values of m and n, you'll have to solve it differently. So case 1 is if m equals 1 or n equals 1, do a u sub. So if you haven't seen the substitution with integration video, I'd highly suggest you watch that. But you just do a u sub. So for example, I'll do this in another color. If I had the integral of sine x cos squared x, then I'll let u equal cos x, so that du dx equals minus sine x, and I'll get dx equals du on minus sine x. So then this will become sine x u squared, and then du on minus sine x. The sine x will cancel each other out, and then it'll just be this as my expression, and I can do whatever. Case 2 is slightly different. Case 2 is if m is odd, use sine squared x equals 1 minus cos squared x. So for example, if I had sine cubed x, which would mean m is odd, and cos squared x, then I can say sine squared x equals 1 minus cos squared x. So this would just be sine x, this is sine x. So sine cubed x is sine x times sine squared x. So I'll write sine x, and then sine squared x is 1 minus cos squared x, and this is times cos squared x. So I'll have sine x cos squared x minus cos 4x, and then from here I'll let u equal cos x, and then this will just be u squared minus u to the power of 4, and when I take du, that sine x will eventually cancel out. Okay, and then for the third case, it's very similar to the second case. So if n is odd, use, instead of using sine squared equals 1 minus cos squared, you use cos squared equals 1 minus sine squared. So if you had, for example, if you had sine squared x cos cubed x, it's just a reverse example of case 2, where I had sine cubed cos squared, now I have sine squared cos cubed. Then I can just write cos cubed x as cos squared x times cos x. So this will be 1 minus sine squared x cos x dx. And then I'll have sine squared x minus sine to the power of 4x times cos x, and I'll just say let u equal sine x. So I'll have u squared minus u to the power of 4, and then eventually this cos x will get cancelled out when I put it in du. And then for the final case, if m and n are both even, you need to use these two formulas. So sine squared x equals half 1 minus cos 2x, or the other one is cos squared x equals half 1 plus cos 2x. So these are just the double angle formulas rearranged, and they look like this. So if m and n are both even, for example, I could have just the integral of cos squared x. So here m and n are both even. In this case m is 0, so the power of sine is 0. which is fine. So I can use cos squared x dx, which if I use this formula, I'll have half 1 plus cos 2x dx. And then this is something that can easily be solved just with traditional methods. It's just integrating cos 2x. So integrating cos 2x should give us half sine 2x. Okay, but I won't do that now. I want to move on to some examples. So evaluate the following. Evaluate the following. So I have sine x cos x. This is a case where this is case 1 where m equals 1 or n equals 1. In this case, both m and n equal 1. So I can do a u substitution. I can let either sine x equal u or cos x equal u. For this question, it doesn't matter because they're both to the power of 1. So eventually, I'll just cancel one of them out. So I'll just let u equal sine x, but just know for this question, you can let u equal cos x as well. U equals sine x, du dx equals cos x, dx equals du on cos x. So then, if I write the whole thing out, I'll have u cos x times du on cos x. The cos x's will obviously cancel each other out. This is just u du, and then that's going to be u squared on 2 plus c, which is sine squared x on 2 plus c. Okay, this second example, it was done before, but I'll just do the whole thing. This is case 4 where m and n are both even. So I have to use one of my formulas. I have to use cos squared x equals half of 1 plus cos 2x. So then I have half of 1 plus cos 2x dx, which is half of 1 plus cos 2x dx, and that equals half of the integral of 1 is x, integral of cos 2x is half sine 2x. So integrating cos becomes sine, but then since there's 2x on the inside, I have to divide by the coefficient of x. So I'll get this, and I'll just plus c. And then my final example is case 3. So this is n is odd, or the power of cos is odd. So I need to use cos squared x equals 1 minus sine squared x. Right, so I'll have cos cubed x is cos squared x times cos x. And I can write this as 1 minus sine squared x times cos x. Now I want to do a u substitution, and I'll let 1 minus sine squared x equal u, because then when I take the derivative of sine, I'll let u equal sine x, because when I take the derivative of sine x, it should cancel out with my cos x. So I'll let u equal sine x. Du dx will equal derivative of sine, which is cos, and then I'll get dx equals du on cos x. My handwriting is a bit bad, but now I can write this integral up here as 1 minus u squared times cos x, and then du on cos x, and the cos x will obviously cancel. So now I'm just integrating 1 minus u squared times du, and then obviously integral of 1 is u, because I'm doing this with respect to u. So I have u squared, I raise the power, it'll become u cubed, and then I need to divide by the power, so u cubed on 3 plus c, and then I'll change this to be in terms of x. So I had u equals sine x, so this is sine x minus sine cubed x on 3 plus c. Alright, now I'm going to move on to integrals involving tan x. So if I was just taking the integral of tan x, I can split that up into sine x on cos x, and then to integrate this I need to let u equal cos x and do a substitution, because when I differentiate cos x I'll get minus sine x, and that'll cancel out with this, so I'll get eventually I'll get like minus 1 on u du, something like that. Okay, and then if I have tan squared x and I'm trying to integrate tan squared x, there's really no use breaking it down to sine and cos because I can't really do anything with that, but I can use the identity 1 plus tan squared x equals sec squared x, right? And then you may know that the integral of sec squared x dx equals tan x. So if I put tan squared x in terms of sec squared x, I can integrate sec squared x to give me tan x. Okay, so I'll just do a few examples involving tan x. So unless it's tan squared, generally you just decompose it into sine and cos. So this will be sine x on cos x times cos cubed x dx. So this is the same as sine x cos squared x. And now if we look at this, this is a case 1, right? I have m equals 1, or the power of sine equals 1. So I just do a u substitution from here. Let u equal cos x du dx equals minus sine x du equals, dx equals du on minus sine x. So then I'll take this and I'll write this integral as sine x u squared times du on minus sine x, and that gives me minus u squared du, and that's going to be integral of u squared is u cubed on 3 plus c, and then u was cos x, so minus cos cubed x on 3 plus c. And that's my answer. And then just as a final example, I have tan x times sec squared x. So I might want to again take this, I'll write this like this. Instead I'll write tan x as sine x on cos x and sec squared as 1 on cos squared x. So this is sine x on cos cubed x, and then this is going to be a u substitution. I have sine on top and a power of cos on the bottom. I know if I let cos x equal u, I'll be able to cancel out this sine x. So if I let u equal, say, cos x, then I'll have du dx equals minus sine x. So dx equals du on minus sine x. Remembering I need to put my terminals in terms of u, since I'm changing everything to u. So if u equals cos x, I need pi on 3, I need the top terminal to be cos of pi on 3. So it's going to be half, and then cos of pi on 4, so 1 on root 2. And this is going to be sine x on u cubed du on minus sine x. So that sine x will cancel out. I'll have the minus sign out front, and I'll write everything out. So that's 1 on root 2. This is half 1 on u cubed, or I'll write this as u to the power of minus 3 du. And then this is going to be negative u to the power of minus u to the power of minus 3, I raise the power and divide the power. So there's u to the minus 2 on minus 2, half to 1 on root 2. These minus signs should cancel. So I have essentially 1 on u squared, half 1 on u squared, half 1 on root 2. So what is this? Half 1 on half squared, which is 1 on a quarter, which will be 4, and then minus 1 on 1 root 2 squared, which is 1 on half, which is 2, or 1 on 1 half squared minus 1 on root 2 squared, like this, and then my final answer is just 1. Okay, and I just briefly, I didn't put an example question for it, but if I was trying to do an integral for tan squared, so say I was asked to find what's 1 minus tan squared x, as you know, evaluating this, I would say, okay, tan squared x equals sec squared x minus 1, so this is 1 minus sec squared x minus 1, which equals just minus sec squared x. So then this will be minus tan x, because integral of sec squared x is tan x, so minus tan x plus c. Okay, so it's really basic, so I didn't add a question on that, but it's just for you to know, hopefully. Okay, that's the end of the integrals with powers of trig functions. I hope this was all helpful for you.